So the purpose of today's training is to teach the fundamental thing about Crowbar 2, which is attribute injection. Attribute injection is a broad range of topics that describes really the way in which Crowbar tells the workers, in this case we would call those jigs. The jig we're going to talk about is chef, and we can also talk about the script jig, but it basically is the way in which data and configuration information goes from Crowbar out into a worker, jig, and then back from the jig into Crowbar to be stored in the system. And in the past, we've called those things a wall, or a data bag, or role attributes. All those things are in this broad category of attribute injection. It is, in the simplest form, it is just how we pass data back and forth from inside of Crowbar out to the systems that have to be configured. Okay?
And how we get it back.
And how we get it back. Yeah. And it maps directly, by design, it maps directly to a chef attribute injection pattern. This was intentional, where chef has a pattern that they call attribute injection that allows you to set attributes for cookbooks and recipes to use. And so it's no accident. What we're doing is actually trying to drive that system, although for us attribute injection is a bigger thing in how it works. Okay. In all this, I know that we'll also have to cover some Crowbar architectural pieces about node roles and jigs and things like that. We're going to try and keep that to a minimum and more go through the pattern of how attribute injection works, and if we can, we'll also even show some of the APIs where you would see things, because that seems to, when I've shown other people this, it's made a big difference to be able to point to different places and how the system works.
Just Parkland, which is part of the Crowbar 2, has its sample of that?
All of the bar clamps, they're part of Crowbar 2, that function
Have.
work entirely through attribute injection.
No, I understand that. I'm just trying to see the simplest example.
The simplest example is probably something like the DNS or the logging bar clamp.
Okay.
The simplest example of actual functional code, code that does stuff to other machines.
We'll bring this.
Please enter your conference passcode. If you experience any issues or need assistance at any time, please press star followed by 0. For the tone, please say.
There we go. Okay, so all right, boy. So this is a very circular conversation. So we need to pick a place to start the attribute injection cycle, and I think the best place to start is the node role template, perhaps.
First,
the role template.
well, I think first I'll give the 100,000 foot overview.
Do it.
Blob of JSON comes from Crowbar, gets passed to Chef. Chef client runs, does stuff, generates another blob of JSON. And we take that back and grab all the information we care about out of it. That's the extremely overly simplified view of how attribute injection works. And then
JSON, Crowbar, jig, chef, do stuff, and then back.
and then back to
And then
different
actually it goes
JSON.
back to the database from that
I have a
perspective.
quick question, sorry to interrupt, but at what point does the database interaction get involved with what you just described?
The database is just a place where we store stuff. There's nothing special at all about it anymore.
Well, but if you're used to Crowbar 2 and you're thinking that we still use Chef, we don't. The database is the thing we store data in. So when it's JSON, it's actually going...
It's JSON coming from the database.
Well, we take a JSON template file, we stuff it in the database, and then we manipulate that. And this whole thing in here is really what we call the annealer. And
Okay, so when I define, this is my question, you kind of answered it a little bit, but when I define attributes in the templating for CB2 in that layout, the second I invoke those JSON files and they basically Crowbar gets a hold of them, they're stored in the database at that point. Is that how it works?
Yes.
Okay.
And that's why I was going to start at the role. So the place where those things start, the birth of those templates, which one do you want to start with, like the provisioner or DNS?
Actually, I think that that page you were on, just with the kind of overview for the last pull request that I had, was exactly at the right spot.
Okay.
So where was that page? You had it somewhere.
Okay, you
This
answered
one?
my question. Thank you.
Yeah, that.
Okay.
Yeah.
It's very
So yeah, I mean, this isn't the full thing of what I want to say, but it does include something very simple. So in Crowbar 2, attributes can be defined on a per bar clamp level, which essentially those wind up being attributes that are applicable to nodes, and they'll get data from either the hints or the discovery information on nodes and put data back into them.
So, yeah.
Those are kind of boring. The ones that we're actually going to care about for most of our work are the attributes that are defined by roles. And roles can both define what attributes they want, and they do that by having a role template.json, which fills out the defaults if there are any for the attributes.
Let me pull one up. Keep going because well, okay. You and I are starting from opposite ends of the pipe.
Woohoo.
The trick.
As long as we get to the same place.
Yep. Oops, sorry, I reopened this. I have to do this. Yeah, good. Okay. All right. So bar clamps. So crowbar. Oh no, we want to start with like the provisioner.
Yeah, go to the provisioner.
Provisioner bar clamp. So the provisioner bar clamp has in the Crowbar YAML file. Let me make this bigger if I can. There we go. Yay. You'll notice there's new metadata in the Crowbar YAML file
For roles.
for roles.
And the provisioner server role says it declares that it knows how to provide a bunch of different attributes. Things like the machine key, the SSH access keys that the provisioner will need, what the name of the server, the IPv4 address of the provisioner web server, the IPv6 address, and so on and so forth.
It can also provide data that it retrieves from the node. So there's two types. This is confusing. We're talking predominantly about chef and jig attributes. There are also node attributes that drive the UI, like the discovery data. That we're not going to cover that right now.
Yeah,
But
we're not covering that right
There are
now.
attributes for that too.
But the attributes here, they consist of mainly three parts. What the name of the attribute is, and that has to be globally unique right now, because that's the easiest way to code it. A description of the attribute for use in the UI if we want to display it, and the map, which is how do we take a blob how we index inside of a blob of JSON to find the attribute in question. And pretty much you just drill down in the JSON blob with that / separated path, and whatever is the value of the machine key is.
So
Is it the role template JSON blob?
No,
it's not.
it's not. It's a little more complex than that. Whenever you are getting an attribute that's been defined by a role, the annealer knows that it needs to get that attribute from a node role. And it's the node role's responsibility to provide that attribute on demand whenever the jig runs.
No, he's entirely right, but there's levels of this that. So this is circular. Please be patient, because the node role attribute information is what actually gets sent down to the node when it has to execute.
Mm-hmm.
But you don't start with the node role information. You start with a template at the role level, which is what I have on screen. So the provisioner, there's a role in our system called provisioner server, and there's a file called role template, and that role template, which that map that Victor was pointing to earlier would index into, this is the template that the role uses. Now, that gets imported into the database when Crowbar starts, and you can edit it, and this is effectively your default settings.
And then when you actually add that role to a deployment, it gets copied into the deployment role for that. And then users can edit that to change whatever values they want because they don't want their default password hash to be Crowbar.
So
because people like security for some strange reason.
role deployment. This is a scope tree. This is really important. So just like Chef has different scope boundaries, we have scope boundaries. The role template is global. When you create a deployment, you put a copy of that role into the deployment. It creates a deployment role, which gets a copy of that template, and that becomes a deployment scoped version of the template. And then when you go and actually implement a node into that deployment, it actually doesn't make a copy, it creates an overlay of the deployment. So if you want to change the deployment scope role template, you can make changes to the node and it will overwrite the specifics. This is very similar to what Chef does, right?
Yeah.
If you're used to Chef, has the same, for no surprises, the same mechanism of the leaves of the tree overwrite the role configuration information up the tree.
So it inherits whatever it inherits and then overrides whatever information it has on top of that.
Correct.
Yep.
So the deployment role template, is it populated based upon what is in the role on the inside the database?
Yes. It's populated based on the role template, and then admins can go in and edit it to whatever they want.
Correct. And then basically now it stores for the role deployment. I presume it also stored on the database, but in some different place. And then every time you deploy, you assign the node role for that deployment, it creates a copy for that node and allows it to override it.
It doesn't.
It creates a node role, but it's a reference.
Well, it doesn't do that because you can only have one deployment role per role in a deployment.
Yes.
Because that's why it's called that. And the node role knows what the node role object knows what role it's referring to, so it just looks it up in the current deployment. If it doesn't find it there, it looks it up in that deployment's parent, and so on and so forth, until it hits the end, or until it hits the top of the deployment tree. And if it doesn't find it there, it comes straight from the template.
Okay. And in the first pass at Crowbar 2 design, we had tried to make all these things singletons in the database. We threw all that stuff out. They are just bags of data that we pass around in the node roles and the deployment roles and in the roles. And then we are creating attributes that don't contain data, they just contain mappings into the JSON blobs.
Correct. But since the node can override whatever is in deployment role, where is that node information stored?
In the node role.
Okay, so node role also in the database somewhere in the.
Don't ask where it's at. Everything's in the database.
Everything's in the database.
So node has the references to the deployment and then whatever additional values it wants to override.
Yeah,
okay.
It's got all the references it needs, and all the logic that it needs is already there.
Right. So when you go to actually make something work, the node role is the node is going to collect all the data from its affiliated node roles, the appropriate data from its affiliated node roles, bundle them up into a big JSON file, and send that to the node for execution. We'll get to what send that to the node for execution means, but I want to cover this piece first.
Yeah.
So this is a pretty complex one because it has a lot of supported OS information. But
the simple one, let's say logging or DNS, whichever one.
Most of those are so simple they don't have any template.
Okay.
So, right, the simplest ones are going to be the test ones because the test ones actually test this capability. So you could look in, sorry, not here. Test. So in the hierarchy, test is top level. Chef is, if there was a Chef cookbook, which there isn't for test. Test actually uses the test jig. So all of its roles are defined under test. So here's some really simple ones. You can set a delay value and a marker and whether or not it's used. Pretty simple. Okay. This information is surfaced in the UI. Okay. Under roles. And then so if I click on it, so this is the roles that are in the system. And if I click on Crowbar provisioner server. Let's see.
Oh, it's not showing.
It doesn't show. No, I chose not to put all that stuff in there. But you can get to it if you do the API v2. What I did, this is really useful to understand, is I just added API v2 to the UI path, and that gave me the JSON object that's behind that. So this is role 19, and it is happily in this. So if you'll look, you can see supported hashed template. Here's the template for that role, and then this JSON data is the template for it. I can prettify that.
So that doesn't appear in the UI anymore.
I just didn't map it through because we don't expect people to mess with it there. The place you would mess with it is in the deployment role, and I don't have any active nodes in here, so I don't have any.
To show that.
There's a way to show it, but I'd have to propose it.
So until the latest pull request that I have out there gets pulled in.
So here we go. So yeah, Crowbar. Oh, this only did the test. I didn't pull in all the. That's why I'm having trouble. Oh, let me add the test rolls.
How did you get the different color of the background?
I changed the default for the open crowbar by design.
Yeah, he's working in OpenCrowbar, not the all the repositories.
Yeah.
Pattern's the same.
Patterns, the codes. Yeah. So if I do, in this case, API v2, I'm going to get this is the deployment role. And so in this case, there's no template, which is why it's not showing me any template. And you can see there's actually a way to do an override here.
But we're wandering away from attribute injection there.
Well, we are, except that people need to understand where the data, that there's data being stored and passed through.
Yeah, in various different places. They all kind of glom together in the hierarchy that's imposed by deployments and by the node role graph.
Okay. So that's what's happening with the data. Let's jump over. I was going to jump over and show the chef side of it and see where the data needs to be at the end of the day. Do people understand? So we have a room and we have remote. Does it make sense right now? What we're basically doing is building up JSON data that we're going to send to the node. We haven't talked about how we send it. We're just showing the process by which the template gets built for the deployment.
For a single role.
Hey, this is Chris. Can I kind of give a synopsis of what I've understood so far, and you can tell me where I've gone wrong?
Sure. Please.
Okay. So things that can have attributes are bar clamps and roles. So it's much more common for roles to have attributes as opposed to bar clamps. So far, so good?
I wouldn't say bar clamps have attributes. Everything is carried on roles.
Bar clamps can declare attributes, and if they don't declare it as part of a role, then it's a node attribute.
Right.
Which means it gets its information from one of the two blobs of JSON that we track for nodes, which is the discovery information, which is basically oh hi, and the hints, which is a thing Rob's been working on.
Right. So that.
Okay. So roles and nodes can have attributes. Is that right?
Yes.
Yes.
Okay. So the default values, the attributes themselves as well as their default values are declared in the role template file. Is that right?
That's
yes.
right.
The role template file for that role.
So under the jig that implements the role, the name of the roles, the name of the role, and then the role template file.
Okay. So when you create a deployment, it effectively makes a copy of that. I guess it must instantiate the role, right? And it makes a copy of those things. Then you can edit those through the user interface, and the edited versions are stored in the instance of the role. Is that right?
There's a different class called deployment role where it's stored, but basically, yeah.
Right. That's why we don't edit it in
Okay,
role.
deployment role.
So deployment roles are versioned over time, right? They have the snapshot concept. So the reason we use deployment role instead of role to change it is because that allows you to have a time sequence version. You're not editing, you never edit the original deployment role. What you're really doing is you're editing a new version of the deployment role for the next deployment. Right, remember we have this whole proposal concept. Proposal is a whole new layer, if you will. And when you commit that proposal, you're telling Crowbar, move to this new snapshot. We've been trying to make that sort of not have people tied up with snapshots in the UI so you don't see it much. But what you're really dealing with when you make edits are, you're actually editing a snapshot, the head snapshot of a deployment.
Okay, got it.
Okay.
Is there any way to roll back to a previous one?
Defines what attributes are sent
Hold on, Derek.
down
We'll answer that in a second.
the chef recipe. Is that something that's declared in a role template, or are just all of them sent down right now?
Right.
He's in the middle of changing that.
I'm in the middle of changing that, but right now it's just all of the relevant ones, where what is relevant is determined by first whether or not that role is deployed on the same node, or whether or not okay, so let me back up a little bit. When you want to change something on a node, you have to there has to be a jig run, and that jig run is past the node role that essentially contains what you want to change. So like if you want to add the provisioner server role to a node, you have to give it a node role, then fire up the jig, or you have to fire up the annealer, and the annealer will go through and make sure that all the prerequisite node roles for that provisioner server node role have been run on the node and they pass, and then it'll do that. So the attributes come from all of the parents of the node role that you're currently running that have the same node, and any role that is a parent of that node role that has the server flag set, which means that which indicates to the annealer machinery that the results from running that node role should be mixed in with any children of it, which is what allows like a DNS server.
Right. Server information is meant as shared information, so that flag tells it to pass forward any information. Basically, as a search, it's replacing. So it's really important. We're replacing search here. So when Crowbar aggregates this together, we're using the hierarchy of relationships that we have to anticipate needs rather than relying on search.
And what I'm changing it to is that every role declares both what attributes it provides and what attributes it wants to run. So server roles would say, I provide blah, 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 blah attributes with all the mappings that it needs to get them out of the blob of JSON that will be stored on that node role. And any role that needs an attribute that another role provides, for instance, what is the IP address of my DNS server, says, I want DNS server IP as an attribute, and the annealer machine will look in all the parent node roles of the DNS client role to find which is the first one that has a DNS server IP, and it will use that one.
And when you say it will use it, do you mean it will be passed to the jig with the other?
That exact attribute will be sliced out of the parent node roles
and merged in with the node role attribute.
So it'll actually build a JSON blob for that execution. So each node role represents an execution event on the node or somewhere, an execution event. And the JSON data is assembled based on these rules and sent or used during that execution. And so right now it's big, and the work Victor's doing is
it shares too much. It's easy to leak and get stuff you don't want, and I'm working on tightening that up so you only ever get the stuff you actually want.
Are we able to deploy multiple separate, distinct clusters from a single?
That is. So John's question is, are we able to deploy multiple clusters? That is a design objective. It's not one we're testing yet. But the reason why we're doing all this stuff is to create scoping boundaries. So a deployment is a scoping boundary, and you will get data first from your own deployment, and then from parent deployments if it can't be found in your deployment.
Yeah.
Right now there's only one level of parenting, but the idea is, so the system deployment is the universal parent, and then say an OpenStack test deployment would have separate configuration, deployment roles and node roles and relationship data than a production OpenStack deployment, because they have, basically you search within your deployment scope first and then go up. This is the number one thing that made search completely intractable, is if you didn't understand how to scope your searches, and you could only do that by convention, then any one misplaced search would break the whole deployment. And so we're being very explicit. We're giving up search, right, to be very explicit about how the relationships between these roles go.
I don't understand what the problem, wouldn't say, an unscoped, inappropriately scoped search would break the deployment. Does that mean it would get incorrect data?
Yes.
Yes.
You would get data from the other deployment, and you wouldn't know that you were getting. So you would say, oh, I need the IP of my database.
And there are 17 deployments out there that each have their own special DNS server, and you just get the first one that it returns, and hopefully it's right.
That's the problem. That's the thing we're through. Derek had a question about rollback. The goal is not to be able to roll backwards, but to roll forwards to a previous configuration, if you accept the difference. So what I'm saying is, we don't have the concept of rollback, and I don't expect us to have the concept of rolling back, but I would expect that you could take a previously successful snapshot and set it as a new target, and you could go forward to a previously known good state.
I was thinking more for like a service provider role, where you'd want like a base of things that are available for all your customers or all your users, and then you'd say, oh well, this subset wants this thing, so in a way it's like using it as a meta template. So you've almost defined your own template by having one set, and they say, well, these need to roll forward and we're going to apply them there, but actually now we want to go back to the original and apply a different set of mods for this group here.
Totally,
if that makes any sense.
But not yet. So
okay.
It makes perfect sense, and we expect to have treed deployments to handle that use case.
Okay.
But it's too complex for us to implement right now.
All right.
Derek, question for you. For the testing framework you're using right now, when something fails during the test, and when you start a new test, how do you roll? I don't want to call it rollback, but how do you return to the known point to continue the test suite?
You don't at the moment.
Yeah, the current reset to known point is called nuke it from orbit.
Yeah,
that's very helpful. Okay,
and we're trying to make delete work much better. By the way, it's one of the first things we need in Crowbar 2 is clean delete.
Naughty question here: are we enabling file system hierarchy standard compliance in our overall architecture?
That's completely irrelevant to the discussion at hand.
Why are you asking that? Why are you asking about file systems?
Because he's stirring the brown stuff.
In terms of pathing that we pass in the attribute, the attribute.
That has nothing whatsoever to do with file systems at all.
It's not a file system that
Slash TFTP boot does.
It's not a file system.
The hierarchy of the JSON is not file system based. There are file system references in there that must be compliant with the OS that you're going to deploy, which is why these things are broken out by OS in this case.
Yeah, but how we are injecting and retrieving attributes has nothing whatsoever to do with the file system.
So let's talk about how we inject attributes.
Do you understand FHS?
I understand FHS, and that's why I understand that your question is completely irrelevant to what we're talking about now.
This isn't the right time.
Yeah.
So where's a good cookbook? Because Provisioner doesn't look like it uses attribute injection at the attributes file in Chef.
Nothing that we have uses an attributes file in Chef.
Oh, that makes sense. So let's look at the StackForge stuff.
Okay. The StackForge file does. You use an attributes file, which is why I have as the third thing on the whiteboard is cookbook role defaults and cookbook attribute defaults from Chef, because those are the defaults that are used if nothing else does, or if nothing else defines an attribute.
I was in the right space.
Derek, think through as a QA team what requirements you have for testing.
A larger brain to understand all this to begin with.
Okay. I can't help you with that. However, I can provide some beer.
Okay. Well, really what we need, I mean, this is all good background material, right? And it helps to know. But from a QA perspective, we need a workflow. Everything comes from a workflow in QA. Anything other than that is just functional testing.
So I'm afraid this conversation isn't really that helpful to you right now because it's pretty tightly developer focused.
I get it, and I'm monitoring this and just trying to get it for background and better understanding.
Yeah. Where's the actual code for these guys? Why am I missing that? It's in Stack Forge OpenStack repo, isn't it?
And you're looking at...
These are the roles. This isn't the...
Well, they do environments and roles.
Oh, it's in their environments.
Yeah.
So
No, that's example.db.rb, and there are your attributes. Yay!
Okay.
You got
I was looking for an attribute dot.
JSON?
Yeah.
Yeah, they don't do that.
No, it's not. No, it's usually an attributes.rb file.
Well,
By convention.
yeah, that's just a convention, though. If you have more than one set of attributes, though.
You can't do that.
Yeah.
All right. This is
So the way that we get our blob of attributes into Chef is the Chef jig, or both incarnations of it, both the Chef jig and the Chef solo jig. They generate a role that has all the attributes that we get from
A chef
Crowbar, a Chef role. They generate a role with that set of attributes as the default, and they make sure that that role is included in the run list before the role that actually implements whatever it is the role implements. So for like DNS server, we have a DNS server role, and it has a little run list in it, and we just make sure that the role with the blob of attributes is in the run list before the role that actually, the Chef role that actually does something. So,
which is simplified by the fact that we're doing Chef solo.
well, it works the same way for a Chef server.
Can you
Not true.
Yeah.
elaborate on the difference between chef and chef solo?
Chef solo runs completely standalone and doesn't talk to a server.
So you don't. So
Wait, it's like chef client?
It is exactly like Chef Client, except it's called Chef Solo, and it never talks to a server.
So right, it doesn't rely on search. So the feature you lose is search when you do that. Right, because normally what happens with Chef is when you do a Chef client run, it goes to the server, it pulls down its big old blob of JSON and its run list, and then it executes against that the JSON.
So you execute chef solo via SSH.
Yep.
And how do you pass the JSON to it?
We copy that over.
To a place in the file system?
Yes.
And then address.
We copy it
reference that
over.
when you-
We copy it over to var chef roles name of role.
So this is really significant, and I want to repeat this because you're asking the questions. I want to make sure it's very explicit. So when we want to execute a recipe, we collect all the JSON data for that recipe. We save it as a file.
On the node.
On the admin server first. We build it, right? And then we open an SSH session to the node.
SCP all the crap we want.
We copy that JSON file there. We copy the cookbooks and recipes that we need over there. We copy all of the stuff we need
Every
for
time
that run.
every time.
Not every time.
Well, yes,
some
right
logic.
now it's every time, and that will not scale, but it's easy and it's pretty damn fast.
It's very handy if you are debugging and troubleshooting.
If you're developing, it's incredibly handy.
Then you don't actually have to go to the Chef server and upload. You fix the recipe and then you re-execute, and it copies everything over with all new data, and it reruns it.
Yeah, I can see.
It's very handy. And so let me finish this very explicit. So what happens is we bundle up all this information, we open up an SSH session, we copy everything that's necessary to execute that role on that node, JSON data, Chef data, all that stuff. We run that with a sequence that says, here's the JSON data, here's the recipes that you want to execute all that stuff. We take all of the output from that, and which includes
Is that delivered from standard out?
yes.
Two places. Standard out is where we get all the errors and all the logging information for what Chef Solo did, which is another very important thing that we capture. And we also have an incredibly cheesy recipe whose entire job it is to run at the very end and grab all of the override, not the override, but the automatic and the normal attributes off of the node and save them to another blob of JSON, which we then SSH back on the admin node, parse it and load it, and that is essentially the data that we get back from the jig.
Squirrels.
The automatic and what?
Normal.
Which are basically the JSON hierarchy that would get stored on the server. So when you go to look at your JSON objects, you're just getting those things back. So we're effectively getting this, we're pushing the data that you would normally get from a server interaction. We're retrieving the data that you would normally report back to the server at the end. We're taking those things and we're stuffing them into the node roles. And also the log output of actually running it. And we keep that too. Now, one of the nuances in this, there's a couple of nuances. First, that's really simple. If you're developing a recipe, that is a very straightforward pattern. It's one of the reasons why in the industry people really like Chef Solo, and why a lot of people are using it, and this pattern is actually very common. The other thing that's really nice about this and is important to realize is since we're snapshotting the node roles, that this interaction on the node roles is not replacing all the old data. When you do the proposal loop, you're creating an empty node role to capture the next data.
Not in the latest sample.
Oh, okay. Damn it. Damn it.
We're still doing snapshots though. I've just changed the granularity from snapshot at the node role level to snapshot at the actual data that we store in the node role level.
We've been talking about that. We're still, when the data changes, you get a new copy of the data. So we're not, like in Chef, there was no history. And you would be like, I don't know what changed. I don't know what it was. I can't go backwards. I can't, right? In this case, we actually are creating these timelines so that if you had something that worked, we don't implement this right now, but you could eventually go back to it, which would make me happier. Yes. That way, and the other thing that's really helpful here is because we're doing one node roll at a time, if it fails, we stop. And we don't keep going. Chef doesn't keep the activity on that node and all its dependencies will be blocked. And wait.
Yeah. On the Chef side, no matter whether we're running with a Chef server without, we're only ever running the roles for one node roll at a time.
Per node.
Yeah.
We can run multiple nodes in parallel based on the dependency graph, but only one node roll runs at a time on a node.
Gotcha.
Because that has to be sequential. Otherwise we get to multi-edit issues. Right. And one of the things that happens based on the annealing pattern and the dependency graph is that you might make a change to a node role that then causes a upstream node role to change.
Downstream.
Well, or upstream even, if you change the DNS entries or something like that in DNS database.
That's not the common.
It's not the common one. But since we can either repeat cycles if we have to, or we can then impact downstream decisions. That's the easier case because those don't get passed.
And the instances you're talking about, I've arranged it such that like DNS client doesn't depend on DNS database. It only depends on the DNS server.
Right.
And DNS database depends on DNS server and is smart enough to kick it when its configuration changes. So we don't have direct loops. We don't have loops in the dependency graph.
So no, but the point is that if something changes in your dependency graph, the system can detect that, and then that becomes the first thing executed. So we actually keep, if there is a sequence order, if things change upstream from you.
And when you say things change upstream from you, meaning someone is editing a deployment or creating a new deployment?
Well, someone goes in and decides that they want to run 40 Nova Compute nodes instead of 30. And everything that depends on Nova Compute can notice that change in the deployment and rerun as appropriate to update whatever they need to update.
What about changing the parameters for deployment role while it's waiting to be, it's not executed.
It's an excellent question.
Not yet on the node, but waiting for condition to be right.
So a deployment has a proposed state when you can make edits to it, and it has a committed active state when you can't. And so if you want to make changes to a deployment, you have to, the deployment has to have a be in the proposed state.
You gotta essentially propose a new snapshot.
Right. You can't change, once the information's committed, it's running, and you can stop it from running, but you can't change what you committed. You have to add new information and then recommit.
And you can delete the previous one?
No.
That's not.
You're overwriting it and replacing it. But you're not you're creating a new instance for it. You're moving
Correct.
a pointer to the next one.
The previous one was still in the queue.
It's a journal deployment system.
Yeah, but the previous one is still in the queue, so they execute.
Well,
No, you can stop it. Yeah, you can stop it from.
You can stop it from running.
At which point
Well, it was never run to begin with. So
If it's never run to begin with, then it was never committed. The moment you commit something, it starts running.
Right. It's either to do or blocked.
well, it's blocked. So it's basically
Well-
I deployed, I committed something.
Blocked is a node roll state, not a deployment state, and not a snapshot state.
Question, if I make a commitment, it's working on deploying it, I then change my mind, make a change, do I have to wait for the previous one to finish before it goes to the new one?
You could just stop the old one.
You could let it run. Or you could stop it.
The system won't automatically stop.
The system will not automatically stop it.
But then when you stop it, it's up to you then to go and clean up whatever that had been done up to that point.
Well, you don't. You just replace it with the new stuff.
We always roll forward, we don't undo.
Right.
Right,
Exactly.
but so then if you modify the deployment role, for example, you decided that, you know what, one of the attributes you don't want to touch, but it has a side effect, and if it was, the previous deployment, it was modifying something, then it's still up to you to go and undo that.
Well, you don't undo it. You just rerun. You just wind up rerunning all of your node rolls with the new information.
Correct, but that
And
information
God
is
willing,
missing.
your recipes are idempotent enough to figure out what you're doing and fix it.
And that's the trick. Your recipes. There's always been an assumption that your recipes are idempotent enough to deal with changes like that. We've never had that.
If state A has, let's say, a DNS server, and state B, which is the one I'm choosing to go to, does not, what happens to my DNS server? Does it get turned off? Does it get deleted?
Oh, nice question.
It just overwrites the whole thing?
Nope. The DNS server continues doing whatever it was doing before. It's just now we don't know that it exists, so we don't manage it.
Correct.
And that's kind of welcome to DevOps, which is why nuking from orbit is the only way to clear your config.
I was about to say that could potentially leave lots of stuff laying around.
It does.
Well, this is back to the puppies versus cattle argument,
Yeah.
right? So the puppies versus cattle argument is that
You just made that up, didn't you?
no.
I've never heard that phrase before in my life.
Well, it's normally pets and cattle, but I like dogs.
Cattle versus.
I've heard cats and kittens. I've had pigs and puppies. The one that has been winning is cattle and puppies. Basically, what it means is that there is nothing unique in the configuration. They're all different, but there's nothing particularly special to protect. And so you would just destroy a node. You would just destroy the configuration of a node and bring back a new one with the functions you want. We could probably do better, and there might be enterprise cases where people want cleanup actions. So far, the DevOps
It's hard
industry,
to find a recipe that actually provides cleanup
Yeah,
actions.
I know. We always
It's
talk
not
about
a recipe. That's another recipe which you can basically.
Yes, it's hard.
Just like we have a role.
People don't write them.
People don't write.
I agree. It's called
And-
air conditioning. People
and so-
are really bad at that.
So what we're looking towards is making much cleaner delete capabilities so that you could nuke a node and bring it back and reconstruct it really quickly, which is really the mode of operations of cloud deployments anyway, because it's so cheap.
I just like being able, when somebody asks me what happens to X, and I go, I don't know. So.
What happens to X is it stops being managed from that perspective, and when the system gets recycled, it would be that configuration would be lost, and the new one would be reestablished. that's the way to describe it.
You will have multiple DNS running simultaneously in your zone.
It's
a
HA by
reasonable
design.
question.
So.
So let me actually can we point to the provisioner and you can show actually how the JSON blob that we showed for provisioner server gets actually picked up by the recipe. I think that would be really helpful to show people.
Yeah.
Barclamp provisioner.
Well, the problem is none of that happens in any of the bar clamps. It all happens, in this case, as the Chef Solo jig does its thing.
Right, but we should be able to. So, but this JSON in some sense, is getting more or less pushed directly to the Chef Solo cookbook, and this code over here is reading that configuration. How does the JSON data on the left get picked up by the?
So we've got roles, and we have our provisioner server role. Got the role template.json, and we go back up here, and we've got the provisioner server RB, which is an actual straight up chef role.
Right.
And it says we need the utils recipe, we need make SSH keys, we need an NFS server, and we need setup base images. Pretty much all the work that happens when you're setting up a provisioner server happens in setup base images. So we jumped back up there to our cookbooks, provisioner, recipes, setup base images.rb, which is among the ugliest of the recipes that we actually have in any of our cookbooks ever.
Good choice. Good choice for an example. All right.
And we can see a couple of things. This recipe both sets attributes if they are not set, and gets attributes if they need to be got. Like setup base images is what.
So where's it actually getting an attribute? Where's the attribute retrieval?
Where is attribute retrieval?
Like
right there.
Okay, so the node crowbar provisioner server web port path
is an
attribute that we passed in.
Right.
Right.
Show it in the JSON monitor.
Right. So in that so perfect. So in this
Crowbar
JSON
provisioner server.
It's at the bottom.
Web port. Okay. So what happens is when we bring in this JSON, we attach it as a role into the run list. When you do that, it becomes automatically available through this schema of addressing, which is very chefy.
Yep, and that map is pretty much defines that.
Right. So in the past, you might have had to get this information using a search string. You don't anymore. You code it explicitly in this. The pattern that's being used in the upstream cookbooks is they actually create a single attribute and do this map in a single place, and then you use that attribute throughout your code. That way, the maps. What we're trying to avoid is you don't want this map.
We want to migrate these recipes into using that pattern exactly, but there's this little thing called it'd be a nice cleanup, and we've got bigger fish to fry.
So don't we have isn't there an example of doing just that somewhere?
Yes.
Where they set.
Then you do that for Ceph?
Attributes to some.
Override through another role.
For Ceph, I did a couple of providers that did some stuff like that.
Chef
like in the default
cookbooks. I actually thought the Ceph cookbook, has an attributes directory, and in the attributes directory.
Yeah, those just define what the defaults are if nothing else defines them.
Right. So they're doing the same. So this is their defaults, which are really handy. Nice to have safe defaults. And then there is where is it? I thought there was a pattern. I've seen it. There's a pattern where people actually write the attributes as effectively global variables.
Yeah.
And then all of your search or whatever that string is, you don't want that peppered through your code because that's very hard to maintain. You want to say, all right, I just need my database IP, and you refer to
I think a number of the OpenStack recipes do that.
They do.
Yeah. We don't do it internally because, well,
We just haven't yet.
yeah.
It's definitely a cleanup that we want to do, but
Well, and that'll be.
But from the point of view of how we're handling attribute, it doesn't actually change anything of what we would do on the Crowbar side of things anyways. So.
this is my point about, I've made this comment a couple of times to different people. There's two bodies of work for this. One is taking cookbooks and making them attribute injected, which means cleaning up all the places where you've pulled data out and making it consistent. And that's actually the bigger part of the cookbook refactor than anything else we're doing. And while we do that, it's helpful to also then clean up to use a single, the injection point for attributes pattern, so that you don't have that attribute sprinkled throughout the code. And since the OpenStack cookbooks have already done that, they are easier to migrate for Crowbar 2 in a lot of cases than our own.
That's why I want to use. That's why I want to use the upstream cookbooks, is because they're already written with attribute injection best practices in mind, and ours are not.
And it's a significant cleanup effort to clean them up. And so, because if you just miss one place in the code and leave the wrong path or a search, the whole thing is going to fail. Inconsistent. Actually, it'll fail faster because with Chef Solo we don't have search. So
If the moment you try to search for something to go, you try to search for something here, and we
very
can't do
easy
that.
to find all the places.
Yeah.
very easy and level of pain. You can have something that's easy and very painful.
Yes, but with the upstream cookbooks, you can see what all attributes it wants by looking at what all of its defaults are.
Right.
Like in that attribute section.
They put it in one file.
Yeah.
It's in one place. Well, let's say right
attributes.
brackets.
Like all the attributes that are defined in here, those are the only ones that Seth wants.
Right. Somebody asked me.
We target those.
At some point, what we're looking at here actually directly maps to the node, the role template files that Crowbar uses. There is effectively a one-to-one correspondence, and conceivably we could pre-populate those things from here or vice versa. That's just more code to write. We haven't done it yet, but without a doubt, you should look at this file that I'm showing you, the Ceph cookbooks attributes default, and say, oh, look, there's for this. Well, this is default.
I think this has drifted a little bit from what's actually in the recipes, and I should clean that back up.
It probably has. But so you should be able to find the MDS role and find these, init style and secret file in the role template file. As a matter of fact,
Yeah.
I will do it. And so let me keep going back.
So Victor, where is the code that picks up the default .rb, parses it, and passes it through the jig?
It doesn't exist because we don't need that. The default.rb is what the recipe will use in absence of Crowbar overriding it with anything else.
Okay, in place of that, but can you show me where to look for code that describes how the attributes are injected through the jig?
That's kind of what we were talking about for 10 minutes.
The code is in the role is in role predominantly. Sorry.
Under models.
Under models in the role in the role model.
Well,
Okay,
but it's also there's a trick. There's a little bit of it that's in the run model, and there's some of it in the node role model.
the latest set of pull requests is standardizing where all that's at into the top level jig. Stage run and the top level jig is going to be the place to collect all of the attributes and pass them on to.
So this
The
is
actual jig to
and
run.
this is going to we're working through where some of this stuff should go. Victor and I in some cases stuffed it into places that we thought were right, and we've been moving things. The way jigs work is there's a base jig that is the super class for chef, test, no op, everybody else,
And everything else.
for script. And so those things, they effectively, a lot of this prep work for getting the data ready to send to a jig is logically honed in the jig model. The other thing, yeah, and then we have override. So a bar clamp can provide a jig, and so everything we're describing for the chef jig, which is what we've been focusing on, also works the same way for the script jig. So the script jig is The script jig basically is an SSH session that runs a script. And what it does is it bundles up a JSON file and the scripts. It sends those into an SSH session. It executes the scripts in sequence out of the scripts directory. Those scripts have to be smart enough to look up data in the JSON data bag that they want and leave a JSON data bag. I don't know what they leave behind in the script jig, but basically they do the exact same thing. They look up data out of the JSON data, they execute, their standard out is pushed back.
Is there a little script library that has those JSON access functions?
There are, it's in the script jig, which is under, in the Crowbar, Crowbar, the base of Crowbar, there is a script directory that has the script jig in it. And there's, if you look in Crowbar, there's actually metadata that says, tells you what jigs you have. So like the Crowbar base includes the script jig, the no-op jig, and the test jig. The chef bar clamp includes the chef jig, or chef solo jig. And this is a little bit confusing. So there is both a chef and a chef solo jig, but they effectively have the exact same input. As a matter of fact, you won't find the chef solo files. You'll only find chef files, and we link them as chef solo because they're exactly the same. It's a little confusing. We actually, I want to clean that up.
a better way to do that.
I want to clean it up.
So I used the most expedient thing at the time.
Yeah, I would like to rename those to be Chef Solo or something else.
Yeah.
Because Randy and I actually ran into a case where we were editing files in the Chef thing, and it wasn't doing anything because it's all Chef Solo. All the cookbooks use Chef Solo. So
Well, that's why I made all the Chef Solo stuff symlinks instead, so it doesn't matter where you edit them.
So I will note this. This will get fixed, but for right now, it is confusing. You edit the files in the Chef recipes directory, but when you actually do a deployment, they are copied into the Chef Solo area and run out of Chef Solo. It's a little confusing. We will clean that up as part of OpenCrowbar migration.
Yes, but the code that I have here is the way the world is shortly going to work, hopefully.
If I get off my butt and actually review pull requests.
Yeah. Pretty much, we figure out of all the attributes this node role requires, which ones come from nodes and which ones come from roles. For the node ones, we just suck them in based off the role data. Then we pull in all of the parent node roles for this node role that are on the same node, and we pull in all their attributes. And then for all of the role required attributes, we look through all the parents to see which ones provide the attribute that we want, and we suck it in from there. And if we don't find it, then we whine a lot and die. And once we've done that, then we mix in the attributes from the node role that we're going to run, and that combined blob of JSON is what we hand to the jig to run with.
I'm not clear where the node attributes come from.
The node, either is discovery information,
Yeah.
or from hints.
So
What's a hint?
Rob will explain that. Because he wrote it.
Yeah. No. So is the discovery path clear? Discovery path is pretty straightforward. So discovery is we hi data.
Yep.
We take a big blob of JSON data. We stuff it into the node on the node object, and then we have mappings out of that data. We don't store it anywhere. We just map out of it. That's a discovery attribute.
We have data and a regular time interval.
Every time Chef does something to a node, you automatically get back all of the discovery data for free, so we just grab it and
Just change
stuff
it.
on the node.
But it's
in
not
that
stored
case,
in the database.
it is stored.
It is stored in the
I thought you said you don't store it.
We don't store the individual data of the attributes anywhere.
We
The
just store the
attributes
blob
are
of JSON.
always maps back. Attributes are always maps back to the JSON blob.
Is it also stored on the node itself?
Yes, it's
Or
factored
we could
from.
pick
It's,
it up
it's,
by
it's
node.
retrieved. It's collected from the node, but it's not archived on the node.
Yeah,
So
because
we
discovery
can't control
data,
that.
well, discovery data is
It's
essentially
temporal.
regenerated on demand.
Okay, so
So
it's
hints.
that, and then the hints are.
All right, hints are a user mechanism, not a node mechanism. So there are times when you want to inject into the node role engine, into the annealer, hey, you know what? When you come to make this decision, I'd really like you to do give it this IP address, or assign me, map this name to this MAC address, or things like that. Basically, when the machinery of the system is working, we wanted a way to take data and inject it and basically make suggestions of what configuration you would like to have done. So when you create a node, you can say, you know, I'd really like this node to have this IP address.
But how is that? How do you say that?
That data is stored in the hint field of the node
As a blob of JSON.
A blob of JSON.
How do you, as a human, provide that data?
It's part of the API. There's an API.
It's through the API.
Yeah, there's an
Not
API
the
call
UI.
for it.
Right, there's no UI for it. Because
Yeah.
there's no node creation, it's only done on node creation right now. So when you post in to create a node,
You can pass
you can pass some hints. And when you do that, it gets stuffed into the hint field.
Where do the values come from for your hits?
The hints come from the API. Their user, when somebody makes an API call to create a node, that's when you pass in the hints.
There's additional hint.
It's metadata on the node.
It's additional arbitrary metadata. pretty much.
Metadata on, right,
So
it's
you
not.
can create a
Will
meta.
will there be defaults that get piped into hits
No.
in the framework? No.
No, because the default is the code doing its own thing. So, for example,
So
IP address is a good
override
example.
defaults. I'm just trying to understand. Hits override defaults.
Hints provide the mechanism that's making a decision with what you with a preferred choice. So, for example, IP address is really simple in this case. So, when we assign an IP address to something, to a node,
We just pick
we
the first available.
pick the first available out of the database. Okay. You could, when you create a node, you can say, you know what, I'd really like this node to be 192.168.124.90 because that fits my scheme better.
But that attribute has to exist already.
Here's the reason we needed hints. The attribute doesn't exist until the network exists to allocate
But
an
I mean,
IP
that
address for
attribute is
that node.
defined elsewhere besides the hint.
It's not until the node role is applied.
I'm not talking about when, I'm talking about
Eventually.
where.
Eventually.
Where is it?
Hold on. The attribute for hints is defined as a node attribute. So it's defined by a bar clamp somewhere.
Okay,
Yes.
okay. That's what I meant. Is you're not creating new attributes at the hint.
They're not dynamic.
Okay, gotcha. That's what I was trying to clear up.
You could stuff other JSON things into that field, but that would be just like any of the. So this is one of the funny things about this whole system. It is very loose in the fact that we will accept all sorts of JSON data in the discovery or in the templates and stuff like that. We're not trying to be restrictive in what you accept, but we are being explicit in what we map.
I'm going to add optional qualify blah 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 blah
That would
every
be
single
cool.
attribute.
But what we're going to do is but what happens is that we map in and out of that JSON data. So you might have JSON data that nobody cares about, which eventually we don't want to have, but right now we're very permissive. But then you're very explicit in what you retrieve in and out of that bag of data.
So, for example, I can assign the role for the node to be, let's say, controller role. Is
Right.
that assigned as a hint,
Nope.
or is it just a regular?
So let me walk through how the one hint. We have two hints. Let me walk how this exactly how this works, because this will probably help you with the attribute injection in general. So when you create a node, you provide it with the IP address you want. Let's just say .90 for now. Is the IP address I've asked for on the admin network. So you say I want actually just .90. It assumes you want it on the admin network.
We're 15 minutes away from our next meeting.
Okay. And then so.
12 more minutes.
Yeah, and I'm not sure this is really instructive to people coming up to speed.
Yeah, maybe not. Just skip it.
But it is interesting to note in this, the network is the only set of roles that's actually database driven instead of JSON driven. But what happens is it still generates JSON. So while the network bar clamp infrastructure uses database tables to maintain information, the interface that Crowbar gets from those objects, those models, is actually all it's all JSON interfaces.
Yeah, that's primarily because we don't pass database references into Chef to do things. We pass blobs of JSON, and that seems to be the standard for every other tool out there.
and which means that when we create a puppet jig, it's JSON. It's going to accept and return JSON just like Chef does. Slightly, probably formatted differently, which we have to deal with. With that we can deal with those bridges as we get there. Same thing is true with any other type of jig. And script jig is really illustrative from this perspective, because the script jig works in a lot of ways now very similar to the Chef solo jig. That's a lot of information.
What was the impetus for running the script jig?
I needed something to deploy Chef.
Bootstrapping.
Enough said.
It's the nice thing is it's really, and I'll try and close on this point, because I've found that people really this helps people. The control infrastructure between Crowbar 1 and Crowbar 2 is very different. Crowbar 1 was entirely inbound, meaning that you were on a node and everything ran from the node's point of view. Crowbar 2 is effectively out of band entirely, because what's happening is the worker, Crowbar 1 had no workers. It just had Chef doing things on nodes, and you touch Chef to make it go. Crowbar 2 actually has a worker pool where those node roles are executed on a schedule, or in a sequence and in a very controlled way. That worker pool is actually an out-of-band management infrastructure. So when a node role is needed to execute, what we literally are doing is the worker has an out-of-band action. Most all of our current actions SSH into the box and execute in band like we're used to. But that's only as a historical legacy. We could, out of a jig, take any action, like talk to the iDRAC directly, or talk to the switch, or call Rob's mom and say, hey, please set up this server for me. Doesn't matter. That would be a big feat since she passed away 20 years ago. But that might be the best way to hope it happens. Call home jig. So, but it's out of band. And so one of the things I found is really helpful for people understanding attribute injection and Crowbar 2 in general is that it's an out-of-band execution framework where we are SSHing in to execute code on the nodes. Whereas Crowbar 1, everything had to happen on the node and in band. And so, right, you couldn't take any actions in Crowbar without being in the context of the thing taking the action. Right? Even that's one of the failing that keeps SecureWorks crashing, is that in order to change the DNS configuration, you actually have to run all of the friggin' in context node attributes. It takes too long after a certain amount of time. In this case, we actually can be very surgical about making the changes because we're out of band.
You want to change the DNS configuration information, it will run just that.
And so one of the things to look at as you're learning this is to think through, all right, Crowbar 2 does everything from an external point of view when it takes action, which is very different. It's very powerful.